Excellent. So how's everybody doing? Having a good time at DerbyCon? So how many of you, this is your first DerbyCon? This is my first DerbyCon. Good number of people. Excellent. It's pretty awesome. I've had a great time here. Hope you have too. We're going to continue to have some fun over the next hour. Or maybe two if y'all want to stay. You know, there's nothing after this but dinner. Who needs to eat, right, when you're talking about catching bad guys? Okay, so a little bit about me. I'm Doug Burks. First and foremost, I am a Christian. Next up, I'm a husband and a father. I've got a beautiful wife and two adorable little princesses at home. I miss them and they miss Daddy, and they keep sending me text messages. So if I keep looking down at my phone, you'll know what that's all about. I'm a SANS GSC and community instructor, so I teach intrusion detection for SANS. I'm also the Deputy Chief Security Officer for Mandiant. And oh, by the way, we are hiring. We are always hiring for sharp security guys like yourselves. So take a look at our website at our open jobs, and see if there's something that you like that you might be a good fit for. We're always looking for good folks. You can find me on Twitter at Doug Burks, and if you'd like to live tweet this event, you can use #SecurityOnion. So let's talk about establishing the need. So by show of hands, how many of you are responsible for defending a network? Good number of folks, pretty much most of you. Excellent. So for those of you who didn't raise your hand, would you like some more visibility into what's going on in your internet connection at home? Maybe? Yeah? Maybe you've got, a spouse, some kids that are just doing some random browsing of the internet, and, they come to you and, Daddy, my computer is pwned. Whatever shall I do? Well, how did it happen? Let's go take a look. All right, so for those of you who are responsible for defending a network, how many of you have experience with IDS? Good number of folks. So talk to me. How do you feel about IDS? Meh? Meh. M-E-H, meh. How does it make you feel? Are you happy with it? Is it doing a good job? Noisy? It's after the fact? Okay. How else do you feel about IDS? You wish they would let you turn it on. Nice. What else? Any other feelings about IDS? It's hard to set up. Oh, wow. Liam, like you're like a plant or something. I didn't pay that guy to say that, I promise. It's hard to set up. Okay, absolutely. So let me tell you my pain with IDS. Okay, so let's talk about physical security, right? You've got a house, right? So you go and you're concerned about the physical security of your house, so you go and buy a security system for your house, right? You pay all this money, somebody comes out and installs it, but then you find out that all it is a motion-activated camera that takes a snapshot in time, and that's it. So you don't know if somebody walked up to your door, knocked on it, and walked away, or if they busted down the door and stole your 3D TV, right? So that's how I feel about IDS. It's a snapshot in time. It doesn't tell me what happened before the alert or after the IDS alert. So let's talk about network security monitoring. So network security monitoring says specifically that IDS alerts alone are not enough. They're just not enough. They're not enough to give you visibility into your network. They're not enough to allow you to do a proper investigation after the fact. So we need IDS alerts, but we need to surround them with context. This context comes in the form of, in addition to network-based IDS, we also have host-based IDS alerts. So we use a piece of software called OSEC, a host-based intrusion detection system. We also have asset data. So we used to use a program called PADS. We replaced it with a newer program called PRADS. So basically, this watches your network traffic and says, hey, I just saw that one of your workstations started listening on a port 31337. You might want to check that out. We also have session data. So think of this as like NetFlow data, if you're familiar with NetFlow. So just keeping track of all the sessions that are going back and forth on your network. Transaction data. So we have Bro, this amazing piece of software that's doing all of this protocol logging for HTTP, for FTP, for DNS, for syslog, any kind of protocol that it sees and knows about, it's going to write these amazingly detailed logs. So we're creating all of this contextual information to surround these IDS alerts. And now finally, we also have full content data. So we're capturing every single packet that traverses our network. So this is huge, and we're going to see an example of this in a minute. Okay, so to take and surround our IDS alerts with all this contextual data, it takes a lot of pieces to put together this jigsaw puzzle. So you can see a diagram of it here. So what we've been using for years to accomplish this ideal of NSM, Network Security Monitoring, is a free open source tool called Squeal. Anybody tried to build Squeal from scratch? A few people. How successful were you? No, not so much. If you were successful, how long did it take you? Hours, days, weeks? It's a lot of different pieces of software that have to be compiled just right, that have to be configured just right, and gelled together in order to create this beautiful jigsaw puzzle. So what's the answer to this? Security Onion, of course. Right, so I've taken all the work out of it. The idea of Security Onion is to have a free Linux distro for network security monitoring so that you can click next, finish, and have NSM. So what I'd like to be able to do is take any old Windows admin off the street, set him down, have him run through a standard Ubuntu installer, which anybody can do. It's easier to install Ubuntu than it is Windows, right? So you do that part, you reboot, you run the setup wizard, you click next, finish, and any old Windows admin can deploy NSM to his network. That's pretty awesome, right? So a very quick history lesson on Security Onion. In 2008, I started working on the very first version. I released it in 2009, and at that point in time, it only had snort and squeal. The next year, 2010, Ubuntu 10.04 came out, so I said, okay, I'm going to build a new version based on Ubuntu 10.04. So I included snort and squeal. I also added Suricata, a competitor to snort in the open source IDS arena. I added Squirt as a nice web-based interface to the squeal database. And I added OSEC for the host-based IDS alerts. The next year, 2011, people actually started using Security Onion. It was crazy. They were deploying it in production, and I was like, no, what are you doing? You're not supposed to be using this in production. It's just a live CD, right? So I said, okay, well, if people are going to be using it, I guess I have to update it. So I came up with a very cheesy shell script to do some in-place upgrades. And via that shell script, throughout the year, we were able to add Argus, Bro, which I touched on previously, Network Miner, Snorby, a beautiful Web 2.0 Ajax web interface, which we'll see in a minute, and support for distributed sensors. So you can set up a whole army of these to monitor your entire network and manage them from one interface. So that was 2011. So this year, 2012, Ubuntu released 12.04 back in April. So I've spent the last few months working very feverishly. And I'm very excited to say that today, ladies and gentlemen, I'm releasing the beta version of Security Onion 12.04. Thank you very much. Thank you. Stop it. You're too kind. So the idea of Security Onion 12.04 is a few things. So first, I'm going to replace that cheesy old shell script with true packages in a true Ubuntu Launchpad PPA. So just like you would normally install your Ubuntu updates, you're also going to get your Security Onion updates through the same distribution channel. That also means that those updates will be signed with a key so that they are secure. What's that? Is it Adobe's key? Maybe. So this also means that you don't have to use my ISO image. So this means that you can start with whatever version of Ubuntu you want to, whether you like Ubuntu or Kubuntu or Lubuntu or Xubuntu, or Ubuntu Server. So if you want to do just a stripped down, minimal installation, no GUI, you can do that. You install it, you add our PPA, you add our packages, run through the setup wizard, and you're good. This means we also get to support not only 32-bit, but 64-bit. This is huge. Another design goal for the new version is we want to really try to start reaching into higher speeds of traffic that we can handle without falling over. So this means that for snort, since snort is single-threaded and can only go to maybe 200 or 300 megabits per second before it gets CPU bound and starts dropping packets, we have to use a piece of software called pfring to be able to create load-balanced snort clusters, to be able to scale those snort instances up and handle higher amounts of traffic. For Suricata, it's multi-threaded by default. They have multiple means of handling higher traffic modes. So we use AF packet fanout with zero copy. So we're expecting to see some very good traffic numbers there. We also have ELSA, which is written by a guy named Martin Holst. And it's basically like a free version of Splunk. So if you're familiar with Splunk, you know that you can use Splunk for free up to 500 megabytes a day. After that, you have to pay for it. But with ELSA, it's totally free, open source software, regardless of your volume of logs. So we have that out of the box. Martin's done an amazing job on it. Scott Runnels, who is here today, has done an amazing job on packaging ELSA, so thank you, Scott. We will have, even though you can choose your own version of Ubuntu if you like, once we finish our beta period and are ready to release a final version, we will spin an ISO based on Xubuntu 64-bit. Okay, so enough talking. Let's see it already, right? So this is beta software. It is quite likely to fail. I am quite likely to crash and burn, but that's okay. I'm going down in a blaze of glory. Thank you. Stop it. Stop it. Let me get a sip of water before I really get dangerous. All right, so what I've got here is I've got 3 virtual machines. So we're going to set up a distributed sensor network for the DerbyCon network, okay? We're all on the same blue team here. We're all tasked with defending the DerbyCon network. We've got this enterprise WAN, so we've got this huge network that spans the country, and we need to be able to place distributed sensors at choke points to monitor the traffic wherever it may be. So here's my first virtual machine, DerbyCon 1. This is running Ubuntu Server, so this is a minimal installation, no GUI. Then I have DerbyCon 2, same deal. It's Ubuntu Server, minimal installation, no GUI. Those are going to be my 2 sensors that I'm going to set up. And just keep in mind, remember we said before that even if you were to just try to install snort manually, let alone Snorby, let alone squeal, let alone some of the other components, you'd be talking a few hours of work to get it working. What I'm going to show you is in about 30 minutes, getting 2 sensors up and running and finding evil on your network. That's pretty cool. So that's my 2 sensor VMs, and then I've got this DerbyCon VM. That's going to act as my workstation VM that I use for analysis of pcaps. That's what I use for connecting to the sensors and actually logging into the user interfaces. So here's what I'm going to do. I'm going to SSH into DerbyCon 1, and I'm going to run sudo so setup. Okay, so I've got X forwarded over this SSH connection. So the setup wizard is running on the server, but it's being displayed on my local workstation. So welcome to Security Onion Setup. I try to make this as user-friendly as possible, as painless as possible, again, so that any Windows admin can answer a few simple questions and get all this running. Would you like to continue? Why, yes, I would. First question, would you like to use quick setup or advanced setup? So if this is your first time, we recommend doing a quick setup. It asks you the absolute minimum number of questions that it needs to get you up and running. Now, if you're going to be doing a real production deployment, we recommend that you do advanced setup because it allows you more control over what's going on behind the scenes. So for this demo, I'm going to do this first sensor as a quick setup so you can see how quick it is. And then for the second sensor, we'll do advanced setup since it's part of a distributed sensor setup. So we're going to start with a quick setup. So what would you like your squeal username to be? I'm going to be very creative and use my name. What is your email address? Doug@burks.com. What would you like to set your password to? 12345. Okay, ELSA. We talked about ELSA before. It's kind of like Splunk. It's a web-based interface for searching through your mountain of logs. Would you like to enable it? Why, yes, I would. It's pretty cool. Okay, so because we chose quick setup, it has all the information it needs at this point in time to go ahead and configure the system. So it confirms all the settings. Would you like to continue? Yes, proceed with the changes. So behind the scenes, it's going and setting up all of these pieces of software. Remember we had that diagram up there. We don't have internet access, so we can't download rules. That's fine. It's configuring all these pieces of software to talk to each other, to get everything working just right. It's initializing the Snorby database. That's going to be the first interface that I show you guys. We actually have 3 different interfaces that you can use to look at your IDS alerts and the surrounding contextual data for those IDS alerts. It's finished with Snorby. It's now configuring ELSA. This will take just a few seconds longer, and it's now finished. So, ladies and gentlemen, within 16 minutes, and 10 of that was just talking, we now have one sensor up and running. So Security Onion setup is now complete. You can find the setup log here. You can view your IDS alerts using Squeal, Squirt, or Snorby. Bro logs can be found in this location, and you can find them in ELSA. That's pretty cool. Some more information that you can use for tuning your system, because as we all know, every single IDS needs to be tuned. And finally, if you have questions or problems, we point you to our website where we have frequently asked questions, a wiki, mailing lists, all kinds of good stuff there. So we're done with our first box, okay? So let me show you the running processes. Okay, so you can see the Squeal server. That's our back-end central database that all of our sensors talk to. We have a pcap agent. That's what allows Squeal to talk to our full packet capture and retrieve those pcaps. We have a SANCP agent. That's our session data. That's what puts the session data from PRADS into the Squeal database. We have a PADS agent. So that takes our asset data from PRADS and puts it into the Squeal database. Here we have our snort agent, snort, and barnyard. And notice that they have -1 on each of them. So remember I said before that in order to try to scale up to higher bandwidth, especially with snort, we have to be able to spin up multiple instances of it. So that means whenever you spin up an additional instance of snort, we also have to spin up an additional instance of barnyard and the snort agent. So all you have to do if you have, say, a quad-core processor, so by default we have 1 process. If you want to spin that up to 4, you go and change a configuration variable, and it will automatically spin up those additional processes for you. You don't have to do any manual configuration of the startup scripts or the config files. It does everything auto-magically. We've got PRADS. That's responsible for the session data and the asset data. Daemon Logger is doing our full packet capture. We've got Argus, and we've got the HTTP agent that grabs the HTTP logs from Bro and inserts them into the Squeal database. We've also got the OSEC agent and Bro. So that's all of our processes. You didn't have to do any of this. They're all up and running auto-magically. All right, so the next thing we need to do is we need to monitor some traffic, right? This is the DerbyCon network. It's certainly not a quiet network, right? We need packets. So I'm going to use TCP replay on some existing pcap files that I have. That will take just a few minutes. While that's running, I'm going to go ahead and open up my browser to our web page where we're going to have some links. The first interface I'm going to show you is Snorby. So Snorby is a beautiful web interface. It's modern, it's Web 2.0, it's Ajax, Ruby on Rails, all those cool hipster buzzwords, right? So we're going to log in with the email address and password that we specified in the setup wizard. And we don't have anything showing up on the dashboard, so we're going to force a cache update. This should take just a few seconds. There we go. So now you can see on our Snorby dashboard, we have this nice summary view of the IDS alerts that are sitting in our database. We've got high severity, medium severity, low severity. You can click on one of these to show me all of the high severity alerts. Go back to the dashboard, we can scroll down. We can go across here and see things like severities, protocols, signatures, just some nice, pretty charts that management goes ooh and ah over. Sources, destinations. So that's pretty cool stuff. We can go over to the Events tab to see all of our events. So now what we can do is we can look through this list and we can say, okay, we have some IDS alerts here that are, we see the same IDS alert multiple times, right? So let's clean that up a little bit. Let's go to Filter Options and Unique Classified Sessions. So you can see here under Sessions, it's taken and consolidated all those into one single row, and it tells you how many there are. So we can see what's bubbling up to the top. And we see in this case a GPL FTP site exec attempt. Okay, so we look at this and we see, okay, here's this guy 20735, and he's connecting to our DerbyCon FTP server, 192.168.1.102. We can click on the alert and we can drill into it. We can scroll down, we can see the source IP, destination IP, some of the packet data, but remember, this is just an IDS alert, right? This is just a snapshot in time. This is just the bits that matched against the rule, right? I don't have context around this. So can you look at this payload here and tell me if this attempted attack actually succeeded or did it fail? Can you tell me based on the data that you have? No, it's just an IDS alert. We don't have what happened before or after it. We will hopefully at some point in the future be able to pivot from this IDS alert in Snorby to full packet capture data to be able to help answer that question, but we don't have that yet, but I'll show you an alternative in a minute. So Snorby's got some other cool features, so you can, if you want to see the rule that generated the alert, you can click on that and it'll pop up. So that's pretty cool. You can add a note, so you can say, we should probably look into this, and we can misspell it too. So that's kind of cool. So we can drill into the source IP. We can say, hey, show me everything from this attacker. And we can say, oh, yeah, he's doing some port scans for sure. So he's definitely being a naughty boy. We can drill into one of these and then pivot on the destination and see what's going on with it. So Snorby's got some really cool features. It's a beautiful interface. It's got some beautiful reporting. It'll create some nice PDF reports. You can schedule those for a daily or weekly basis. So it's got some really cool features. But we do have other choices. So the second interface I'm going to show you is Squirt. Squirt, apart from having a strange name, is a nice web-based interface for the squeal database. So we're going to log in here, and you see a very similar dashboard to what we saw in Snorby, right? So you've got your summary data here, but one thing to notice is that in addition to having the snort IDS alerts, we also start to see some of this extra contextual data. So for instance, in Squirt, we have PADS data. Remember we said this was asset data. We also have OSEC data, host-based intrusion detection system data. So this is things like OSEC is doing log collection, log analysis, it's doing file integrity checking, it's doing rootkit detection, all kinds of good information about the hosts on your network. You've got other cool charts down here you can take a look at. If we go across the top to signatures, we've got other pretty charts for the manager types. If we go to map, if we had internet access, we could do GeoIP lookups. So you could map those on a globe. We can go across to query, and we could actually say, hey, show me all of the traffic from China, Russia, and Brazil. Well, that's a pretty cool feature. But let's drill down into event detail. So we'll submit this. So notice, again, that we have our standard IDS alerts. So here's an emerging threats IDS alert for Zeus. But notice we also have things like pads. So pads found a new asset on our network. In this case, it found Internet Explorer. So it saw a workstation with IE going out to the internet. Pretty cool information. We also have URL logs. So these are HTTP logs coming from Bro. So think about, you've got a workstation that's been compromised with black hole exploit kit. So you get your standard emerging threats IDS alert for black hole exploit kit. You start investigating that, and you can actually see the kill chain, right? You can scroll up, and you can see the sequence of events where a user went to Google, they searched for something, it led them to this site in Russia, and that began the black hole process. So start thinking again about all this contextual data that's going to aid you in your investigations. So just like we saw in Snorby, we can take an IDS alert, and we can click on here to get some more data about it. Let me get another example. Maybe this one. So you can click into signature. You can see the rule that actually generated that. So that's pretty cool. You've got all this information. You can pivot on source IP or destination IP, whatever you need to do there. Another cool feature that Squirt has is you can go to create and create. It's going to take all of this data and visualize it for you. So we've got this nice, pretty visualization. So, imagine looking at a visualization of your network and actually seeing an attacker pivoting throughout the inside of your network. So that's pretty slick. So that's Squirt. That's the second of our interfaces. So let's now go to Squeal. So Squeal is not a web-based interface. It's written in TickleTK. We're going to log in there with our username and password, and we're going to start Squeal. So the first thing that I want to point out about Squeal is that it's designed by analysts for analysts. What does that mean? Well, you think about maybe some commercial IDS implementations that you've used before where you get an IDS alert. How many clicks does it take you to get from the IDS alert to something that kind of resembles a packet? 8,000 clicks, yes. So over 9,000. Yeah, so depending on what vendor you're using, it may take you 5 clicks. You may have to double click on the IDS alert to bring up a window, and then you may have to click on this and select that and say, hey, yes, I really do want to see the packets. But notice here that in Squeal, I can turn on show rule and show packet data. And whenever I click on an IDS alert, I will instantly have not only the rule, but the packet data. I can also turn on reverse DNS and whois lookups. So in one interface, on one screen with no further clicks, I have all this information at my fingertips. That's absolutely huge. So let's go back to one of the IDS alerts that we saw before. Let's see if we can find it. It was the GPL FTP site exec. There it is. Okay, so remember we were looking at this in Snorby, and we said just based on the IDS alert itself and the little bit of traffic that it captured, we couldn't really make a determination one way or the other whether the attack succeeded or failed. But if we have full packet capture, we might be able to get an answer to that question. So let's see. So in Squeal, all I have to do is control-click on the alert ID, just like that, and I instantly pivot from the IDS alert to the full packet capture for that stream. Okay, think about how fast that was. That was instantaneous, right? No further clicks. I didn't have to go to some other system. I didn't have to drop down to a command prompt and use tspeedump to try to, slice and dice some pcaps. Here it is. So let's take a look at our DerbyCon FTP server and see what happened. So attacker logs in. He issues the site exec command. He sends all of this data, and eventually, what do we see there? Bin sh. What do we see here? The attacker ran a shell, ran the ID command, and it returned root. Did the attack succeed or fail? It succeeded. We now have solved that question, right? We were able to answer the question in seconds by instantly pivoting from the IDS alert to the full packet data. So what else can we do? We can keep on looking at the conversation. We can watch this recorded videotape to see exactly what the attacker did. So we can see him pillaging through the box, looking through the directories. We scroll down a little further. We see him create some user accounts, right? So we're no longer guessing at what happened, right? We know what happened. We know exactly what the attacker did because we have that full packet capture at our disposal. So that's huge. So let's see. We can also, let me find another good example. So what else can we do with full packet capture? Now that we have this awesome capability. So what we did previously is we looked at an ASCII transcript of that clear text FTP session, right? But we could also take that pcap and we could send it into Wireshark, right? So all we have to do is right-click, send the pcap into Wireshark, and now you're instantly looking at packets in Wireshark. So now let's imagine that this was HTTP and there was a file that was transferred through that HTTP session. We can have Wireshark extract the file right out. There's our exe that transpired over the HTTP connection. Pretty slick, right? So within seconds, again, we've pulled the pcap, we've extracted the exe from that pcap. We've got another tool that we can use, and that's Network Miner. So we're going to choose Network Miner here. It'll send the pcap directly into Network Miner. Network Miner, again, can extract files from pcaps automatically. Again, just in a couple of clicks, we've extracted files right from the pcap. Other cool things that Network Miner can do, if this was like a standard web page that had images, it would extract those images and it would show it to you here. Things like DNS queries, it would show you. Things like if we caught some SMTP conversations, it will actually reconstruct emails and show them to you. So that's pretty cool. So are you starting to see like the doors that this opens for your investigations, like how much time this will save you and how much more confidence you'll have about your investigations? Question? Storage. Is there a question about storage? Yes. So the question is, if you're capturing every packet, what does that do to storage? Yes, you need storage. Yes, you need lots of storage. But guess what? Disk is cheap. And I'm talking dirt cheap, right? Recently, I put specs together for a server. It was 8 3-terabyte drives for a total of 24 terabytes, and massive CPUs and RAM. And the server was like $14,000. Now compare that to what you've paid for commercial IDS appliances that don't even do full packet capture, right? You probably paid a whole lot more for that commercial appliance that didn't do pcap at all, right? So yes, there is a cost there, but there's also a cost to incidents. There's also a cost to incident response. Great question. So the question is, do the sensors store the pcap locally, or do they transmit it to the central location? The answer is the sensors store the pcaps locally. And that's great. That's good news for us because we want to keep this data as close to its point of origin as possible, right? Because imagine that you've got a sensor on the other end of a very slow WAN link, right? You don't want to be sending your entire full pcap across that WAN link back to your central database. So we keep it on the sensor itself. So in this case, when I right-click that IDS alert, the central server is actually sending out a request to that sensor. Hey, go and grab me the pcap for the stream, send it back to me so I can send it back to the client. So you've got this distributed pcap architecture that you're just building automagically, right? So you're not having to worry about trying to manually distribute these pcaps. It just happens due to the fact that we're keeping them on the sensor itself. All right. Yes, sir. Every single packet. The question was, are we capturing every single packet or just ones that matched a signature? We're capturing every single packet. Now, there are ways to tune that. So we can set a BPF to say, hey, I want to exclude all the traffic from my backup server or some other system that I just don't care about. So you can tune that to a certain extent. Right, so we have an automatic script that runs every single hour so that when your disk usage hits 90%, it will automatically delete old pcaps to keep you at 90%. Any other questions before I move on? Yes, sir. Real-time capture of what's going in your network? So that's exactly what we're doing. So we're doing full packet capture. Every single packet is recorded in real time. These IDS alerts that show up in Squeal is a real-time event console. So actually, the demo that I'll show in a few minutes, I'm going to do the same TCP replay that I did before, and as those packets hit the sensor, you'll see them populate in the screen in real time. All right, so that is Squeal. And again, Squeal's got all this extra data. It's got your pads asset data. It's got your SAN CP, so you could do things like show me all of the traffic for this source IP in the SAN CP table. Whoops. That's a bug. We're still in beta. I felt like Bill Gates in that Windows 98 demonstration when it blue screened. Oh well. So it has all that. It has the pads data. It has the HTTP logs. So you could do things like, this was a Zeus thing. Let's say we're interested in this IP. We want to go query the source IP table. So again, we see things like the first time that workstation went out to the internet, we saw, okay, here's a new asset. Here's the Internet Explorer browser. So we alert on that. We have our standard IDS alert, a few of those. We have our HTTP log, right? So you could even just go through and start looking at your HTTP logs for interesting domain names, right? And anything inside of Squeal that has source and destination IPs and ports, you can instantly pivot. So even though this isn't an IDS alert, you can still pivot to full packet capture just from an HTTP log. So that's pretty cool. All right, so that's Squeal. It's got amazing capabilities. It's very cool. So we talked about Snorby, we talked about Squirt, we talked about the fact that the VM that I was just running, that I was doing all this work in, what we recommend is that folks run Security Onion in a VM on their workstation and use that for all their analysis because it's got the Squeal client that I just showed you, it's got Wireshark, it's got Network Miner, it's got all this stuff integrated to make this workflow just happen. Okay, so it saves you time in your incidents and everything's ready to go. Again, you can, when you're in Squeal and you, say, pull that pcap out for Wireshark or Network Miner, it's actually copying it locally to your workstation. So you can take that pcap and you can then analyze it with other tools. Talked about the squeal client, we talked about pivoting, talked about network miner, pcap tools. So here's our menu of pcap tools. So once you've got that pcap, you can then analyze it with other tools. Oh, and by the way, this reassembler right here, that's by Mr. Mark Baggett. Thank you, Mark. Very cool tool. Hey, there you go. I talked about the HTTP logs from Bro. That's awesome. So one thing that I like to do is look for user agents on my network. Right? Anybody ever do this? You just take, a few people. You just look at the user agents that are running on your network. You always find something weird, don't you? You look at that and you're like, what is that, right? Maybe it's Bob's evil clown command and control agent, or maybe it's just like Firefox 3, and you're like, why is Firefox 3 surfing the internet from my network? So Bro is logging all this data to standard ASCII text logs, right? So you can use standard Unix command line kung fu to slice and dice that data to your heart's content, and that's pretty cool. Or now that we have ELSA, you can have it do the work for you. So let's do a demo of that. All right, so I'm going to go here and here. We're going to log in with our same username and password. Remember, ELSA is like a free version of Splunk. It's very fast, it's very scalable. So what I can do here is I can say, hey, ELSA, I want you to give me all of the HTTP logs coming from Bro. I submit that query. And there you go. We've got 399 records coming from our Bro logs. With one click, I can say, hey, group by user agent. Right? So no Unix command line kung fu knowledge required. Right? Standard Windows admin. A lot of Windows admins are used to Splunk and the power and the features that it gives you. Same thing here. Right? So just take these logs, group by user agent, start looking through here. Well, Internet Explorer, I kind of expect that. Apple TV. Why do I have Apple TV on my corporate network? Right? So you can click on that and instantly pivot to all of the HTTP logs coming from that Apple TV. Or maybe that was Bob's evil clown command and control agent. You could see instantly what transpired with that user agent. What's that? Oh, vice presidents don't like being watched? Yeah, pretty much. All right, so ELSA also has this really cool new feature that just came out a few weeks ago. So just like you can build dashboards in Splunk, you can build dashboards in ELSA. I have a nice screenshot here because I can't demo this for you because it requires internet access. Otherwise, I'd build a dashboard for you. But you get the feeling here, you can create these dashboards so that your junior analysts can log in, take a look at these dashboards. You can even have managers take a look at dashboards. They love the pretty colors. Maybe that's how you win the VP back. You say, hey, Mr. VP, take a look at this dashboard I built for you. It's all about social engineering the management in your workforce, right? Okay, so we've talked a lot about network-based IDS. We touched before on host-based IDS in the form of OSSEC. So let's talk a bit about that for a second. So OSSEC is awesome. I love OSSEC because it's cross-platform, right? So you can have the OSSEC agent installed on your Active Directory domain controllers, your mission-critical Unix and Linux boxes, your Mac OS workstations, and have them all pointing all of their logs back to your Security Onion box, where they are then searchable via ELSA. Right? So all I have to do here is say, hey, ELSA, show me everything on DerbyCon 1, and there's all of my OSSEC logs from DerbyCon 1. Pretty slick. So I can then slice and dice that data within ELSA. All right, so I talked before about distributed deployment. This is what it looks like from a 30,000-foot view. So what we set up first was our master server, right? And because we did quick setup, that was creating a server and a sensor all rolled into one. Okay, so what we're going to do next is we're going to create our second sensor, right? So that's going to be this guy down here. So it's going to be running the same stack of processes. It's going to be doing snort, daemon logger, SANCP, ELSA, all that good stuff. So here we go. We're going to go to DerbyCon 2, log in, run our setup. Welcome to Security Onion Setup. Would you like to continue? Yes, I would. Okay, now this time we're going to choose Advanced Setup, right? Because we want to create a new sensor for an existing deployment. We just want to do a sensor, so we select that. What's the host name of the master server? DerbyCon1. Please enter a username that can SSH to that box. Okay, so now here, this is where, when we talked about snort and PF-ring, creating a cluster of snort instances, this is where we control that. The advanced setup allows you to control the number of processes that you're going to spin up. So it looks at the number of cores that are on your box, and it says you can create up to that many instances of snort. So I have 2 cores, so I'm going to say, yes, I want 2 instances of snort. I'm only going to do 1 bro instance. Do you want to enable ELSA? Yes, I do. So what's going to happen here, ELSA is distributed by default in that it's actually going to create its own local MySQL database. So all of your OSEC logs, all of your bro logs, again, are staying at their point of origin. We're not transmitting them across a slow WAN link to some central bloated database. We're keeping them where they originated, and we're creating this distributed sensor deployment. ELSA can actually query all those distributed sensors in parallel from that one interface. So do you want to automatically update the ELSA server? Yes, I do. Proceed with the changes. So again, behind the scenes, the setup wizard is configuring all this software for you. You don't have to run VI and edit some configuration file. We're SSHing into the server, creating a key pair that's going to be used for building a tunnel, establishing traffic between the server and the sensor. It's configuring ELSA, and as soon as it's done with that, it's going to log back into the server and do some final configuration there. And it's going to restart Apache on the server. All right, so we're done. So 45 minutes, with 30 minutes of that being talking, we've now built 2 sensors for our DerbyCon network, all reporting together into one unified interface. Pretty cool, right? All right, so setup is now complete. And so now we're back at the prompt, so we're going to do service NSM status. So again, notice our stack of processes, but notice what's different here is that before, remember we had just 1 instance of snort agent, and barnyard. Now we have 2 of each of those, right? So if you've got dual quad-core processors, you could have 8 of these bad boys sitting there chewing through your traffic, and that just happens automatically. All right, so now what we want to do is we want to go back into Squeal, and we want to show you that this is actually happening in real time. So I'm going to go to Change Monitored Networks. So now this new sensor is up and running. Notice we had the original DerbyCon 1. We now have DerbyCon 2. So we're going to select all and start Squeal. Notice we already have some events coming in from DerbyCon 2. So it's already seeing new assets on our network. It's already telling us about that. We haven't even sent any traffic yet. So let's process some traffic. All right, we're processing traffic. If we go back to Squeal, so now you can see this is real time. These alerts are populating. You can notice that some of these alerts are coming in on the -2 instance of snort. Some are coming in on the -1 instance. So that's demonstrating the real-time load balancing of the snort cluster. So think about, if you're monitoring like a gigabit link, right? Maybe you need to divvy that up into 8 snort processes so that they're only having to monitor like 125 megabits a second each. So there you go. Within just a few minutes, we've created these sensors. Everything is up and running. It's accessible within Squeal from one central console. And Elsa's the same way. So if I go back to Elsa, notice that this says one node. If I refresh, it should then say that it found the second node, which is the server we just set up. There you go, 2 nodes. So everything just works. So, where do we go now? So now that I've convinced you that Security Onion is the way to go, I have preached to you the gospel of Security Onion, and you are now faithful followers of the Security Onion. You want to go to our website, securityonion.blogspot.com. I have an announcement that I just put up there this morning about the beta release, so you can click on that. I've got a nice document that will tell you exactly how you can install your favorite flavor of Ubuntu, install our PPA, add our packages, run through setup like you just saw here, do exactly what I just did. We've got all kinds of documentation on the wiki. We've got frequently asked questions. We've got mailing lists. We've got an IRC channel. What more could you ask for? Question? Yeah, with all the work you put into this, maybe some other people, why are you giving this away? Because I'm a nice guy. So for the benefit of those at home, the question was, for all the work that's been put into this by myself and others, why are we giving it away? I personally see it as my mission in life. You know, this is what I was put here to do, because back in 2008, I was looking around for exactly this, and it wasn't out there. You know, so what do they always say about open source projects? It starts with a developer scratching an itch, right? This is a need that I saw, and I said, well, if nobody else is going to do it, I guess I have to, right? I could commercialize it, but honestly, I'd rather, people use it and have something that they can use for free to find and catch the bad guys. That's what it's all about. Yes, sir. Thank you. Stop it, son. Stop. Get out of here. Is there a question back there? So the question is, if you have a sensor with multiple network interfaces, how does it handle that? So it will automatically, depending on whether you choose quick setup or advanced setup, so let's assume that you run advanced setup, it's going to say, hey, I found ETH0, ETH1, ETH2. Which of these do you want to monitor? You can choose one or more of those, and it's automatically going to set up that entire stack of processes for each of those interfaces that you choose. So all that stuff just happens automatically depending on what you choose in the setup wizard. Yes, sir? The question is, how long is the beta period usually? Given that this is our first beta period, there's not much of a usually to it, but I'm going to hope that we can complete our beta in about a month, because I'm itching to get this out there, and a lot of other folks are too. So I want it to happen as quickly as possible. So this is where you guys come in. So test out the beta, see where it falls down, see where it's broken, tell me what needs to be fixed. We'll get it fixed, and we'll get it out there. Yes, sir. So the question is, our big hindrance for a long time was the fact that we were based on 32-bit. And that was a hindrance for a lot of folks in a lot of organizations. So now that we are 64-bit, are there any other hindrances? So the one big hindrance that comes up over and over again, especially with government folks, is the fact that it's based on Ubuntu. There's a lot of government folks that say, hey, why don't you just go ahead and rebuild it based on Red Hat? And that way we could use it. Well, sorry. It's Ubuntu. That's all we can support for now. If we end up growing the community and get a team of guys that say, hey, we want to tackle this, and we want to take all of the scripts, all of the configuration, and we want to port that to Red Hat CentOS, fine by me. That just helps us achieve world domination. But that's really our biggest hindrance to adoption at this point in time. Yes, sir. The question is, what version of Bro do we have on there? In this new beta version, we have the very latest version of Bro 2.1, which just came out. Yes, sir.
With more and more apps and malware going with encrypted traffic, how do you deal with attacks?
So the question is, with more and more traffic being encrypted, HTTPS, what have you, how do you deal with that? So a couple of answers there. So there is one piece of software called ViewSSLD that can do decryption of HTTPS traffic. We don't have that as a part of the distro yet, but that's certainly an option if folks want to add it. It's a very simple piece of software to add, and they can then decrypt that traffic. Another way that I would answer that question is, as the gentleman brought up with Bro is amazing, and it does all of this anomaly detection stuff, especially in the realm of SSL certs. So one of the things that it will do is it'll actually walk the entire SSL cert chain up to the root, and it will tell you if anything is invalid in that entire chain, right? So a lot of times if you're talking about some kind of malware that's using SSL, chances are there's going to be something invalid somewhere in one of those certs. And at least at that point in time, we'll have some kind of an indication via that Bro log that something funny is going on and we probably need to look into it. Other questions? Yes, sir. So the question is, can ELSA accept standard syslog from any other source? So yes, ELSA is based on syslog-ng, and you can basically send any standard syslog into it. So, I mentioned OSEC before. I really like OSEC because it does the log collection, but it also does file integrity checking and rootkit detection. But for those, maybe there are appliances where you can't install an OSEC agent, if you can just do standard syslog, it'll collect those no problem. Yes, sir.
In the alert console, what happens if I lose my WAN link or feedback goes alerts later on?
So the question is, if I've got a distributed setup and the WAN link between the central server and the remote sensor goes down, what happens? So in that circumstance, the remote sensor will queue up all of its data, and as soon as that link is reestablished, it all gets transmitted up to the sensor, the server. Yes, sir. What's the largest number of nodes? That's a good question. Liam, Scott, do you know of any big deployments? Shoop was talking about running on like 30 sensors, but I don't think that's been deployed yet. I think that's being planned. You talking about Alec Waters? He's got a big deployment. I don't know how big it is. But that's one of those things where you guys can help out. If you deploy it, give me some feedback on how your deployment goes. If you deploy 5 sensors, 10 sensors, 15 sensors, I would love to have those numbers. I've asked for feedback on the list before as far as number of nodes, amount of traffic that folks are monitoring. I haven't ever gotten much feedback, so I'd love to have that feedback from you guys. The question is, can you make it work on bonded Ethernet interfaces? Absolutely. So in our setup wizard, not only will it identify standard ETH0, ETH1, it will also look for like BR0, BR1. So if you want to bond it, go ahead and bond it at the Linux level before you run the setup wizard, and it'll automatically identify that. Either way, whether you're running our ISO or whether you're running your own version of Ubuntu, you can do it either way. Any other questions? Yes, sir. The question is, how is our IPv6 support? So the new version of Bro that we have, Bro 2.1, has extensive IPv6 support. Snort has IPv6 support. Suricata has IPv6 support. Prads has IPv6 support. All of our engines have IPv6 support. The issue really comes into play when you start talking about Squeal as an alert console. It really only supports IPv4 addresses. There's kind of a team of us who are trying to kind of revitalize Squeal because it needs to be updated to be able to handle IPv6. So that is something that we're aware of and that we need to work on. But you should be able to use, for instance, you could take all of your engines and have them point their alerts into ELSA, and ELSA doesn't really care about the width of the field, so it should be able to handle IPv6 just fine. Yes, sir? So the question is, beyond the standard first in, first out pcap rotation, is there any way to specify how long those pcaps stay or which specific pcaps are retained? We don't have anything like that out of the box, but I would think that would be something that you could script up yourself. Wouldn't be that big of a deal. Another thing so by default, when it hits 90% and it starts purging out those old pcaps, it's also purging out the old log files from some of the other processes. So like if you want to say, I want to keep my pcaps for 30 days, but I want to keep my bro logs for 60 days. Well, so you can very easily, as that archive starts growing, if you kind of manually prune the pcaps yourself, and get to that 1 month difference in windows, then once that has kind of been established, once you hit the 90%, it's always going to delete the oldest day of each of those data types, so it will keep that staggered difference. So you'd always have your 60-day of bro logs, your 30 days of pcaps. Yes, sir?
Have you seen anyone integrate security onion with commercial IDS,
The question is, have I seen anybody integrate Security Onion with commercial appliances? I know that there are some folks who have done some of that. I'm not exactly sure to what extent or which manufacturers, but at the core of it, you're talking about standard pcaps. You're talking about pretty standard interfaces, so it's standard data. Okay.
So we don't
Fine with me.
stop what you guys are doing. But we're going to make
Thank you. Thank you.